Here we have question 1, and it's making sure we know our indices laws. Okay, so when we've got y cubed times y to the 5, we need to add the top numbers. Okay, why is that? Well, it's y times y times y times y times y times y times y. Okay, so you've got 3 y's times 5 y's, so there's 8 y's. Okay, and if you didn't kind of get taught that from GCSE, that's why we're adding them. Okay, so always think back to that if you forget that. Next one, we've got 3x squared times 2x to the 5. Okay, and we know that when you times, let's say you're timesing a times b, okay, that's the exact same as doing b times a. Okay, and another way why I'm saying that is order doesn't matter when we times two numbers together. Okay, so let's break this down into what it is. Okay, 3 times 2, 3 times x squared times 2 times x to the 5. Okay, so we rearrange this into what makes it easy for us. And you can see this is why we do 3 times 2, which is 6, and then we do the exact same as part A, we add those two numbers. That's why it's 6x to the 7. Okay, and all this workings out is definitely not needed. Okay, lots of people will just do 6x to the 7. Okay, but if you're on this video, obviously this is confusing you a bit. Alright, so this is why we do that. Part C now is 4x squared cubed divided by 2x to the 5. Okay, I always like to write divisions as fractions. So we write as a fraction there. Now this cubed, what is that cubed meaning? Well, it's 3x squared times 4x squared times 4x squared. Okay. And using part B, see all of this is compounding, we know we can just do 4 times 4 times 4, which is 64. 4 times 4, 16 times 4, 64, if you know your Minecraft. And then x squared times x squared times x squared, well, we just add them, x to the 6 over 2x to the 5. Now, we can divide both sides by 2, on both sides, top and bottom by 2, so we get 32x to the 6 over x to the 5. Now, like how we just divided top and bottom by 2, we can divide top and bottom by x to the 5. Okay, x to the 6 divided by x to the 5 is x to the 1. Okay, now, another way to kind of convince you we can do that is x to the 5 is x to the negative 5. Okay, so 1 over x to the 5 is x to the negative 5. Okay, so what we've actually got here is x to the 6 times x to the negative 5, and using our adding rules from beforehand, we add them together, which is x to the 1. Okay, so whatever makes most sense to you, kind of remember that when you're doing these, but these are indices rules that we've got to know. Okay, now part D. Okay, we've got 4b squared times 4b cubed times b to the 4. Okay, first I'm going to look at the numbers when doing this. I'm not even going to write it out again. I know I've got 4 times 3 times the 1. We've got 12. And then b's, we've got b squared times b cubed. Okay, b to the 5 times b to the 4, b to the 9. Okay, because we're just adding these numbers. 2 plus 3, 5 plus 4, 9. Okay, 12b to the 9. All right, so this, you should be able to do these without any steps. Okay, that comes with practice. But this is the reasoning kind of behind why everything is working. And in brackets now, something that A level you need to be able to do it without even thinking. Okay, so A. All right, I'm going to show you that this is kind of step 1 in expanding. Okay, you don't have to do this minus 5 plus 3 in your head straight away. Okay, but you shouldn't need to have to write these anymore. Okay, you should be able to kind of in your head systematically go, okay, x squared minus 5x plus 3x minus 15. Okay, perfect. And then you can then simplify. Okay, whatever makes you have the least amount of mistakes. Okay, realistically drawing this extra line is not going to kill anyone. Okay, next one, part B. Okay, especially when we have these 2's and these 3's in front of the x's. Okay, it can get quite confusing. Alright, so we write out the 4, so you know you've got the 4, and then we can simplify. last one. Okay, now with 3 numbers here. Okay, we can still do the same thing. So we got 6x squared minus 2xy plus 4x. Okay, there's no point trying to simplify this yet. Just write them all out and then collect like terms. Okay, now here we can look for our like terms. We've only got these x's, which are the like terms. So 6x squared plus 19x minus 2xy plus. Okay, and this is something that you should really be confident of. And if you're not, then make sure to get a good amount of practice in. Question 3, we've got a bit harder because we've got triple bracket expansion. Okay, so let's look at part A. Always do the harder brackets first, okay, because then times by x afterwards is always easier. Okay, so we'll leave the x on the outside and we'll do the middle and the right one. Okay, so we've got x squared minus x plus 4x minus 4. Okay, collect like terms. Now we just use to times every term by x, and that's our final answer. Now look at B. Okay, so we're going to, there's no reason to pick what, so we're just going to work left to right. So we're going to have x squared minus 3x plus 2x take away 6, x plus 7. Okay, collect like terms before we expand that. And now we expand it, so x cubed plus 7x squared minus x squared minus 7x minus 6x minus 42. Okay, collect like terms, we've got x cubes, we've got x squareds, we've got our x's, and we've got our normal numbers. Okay, and that's our final answer there. Now C, I'm going to rearrange this so we're doing this times A, okay, because it's going to be the difficult one. So we've got 2x plus 3, and then we've got 3x minus 1, and then we've got x minus 2. Okay, no real need to do this, but I think it's going to make it a bit easier. Okay, so what do we have here? We have 6x squared minus 2x plus 9x minus 3, and our x minus 2. Collect like terms, x squared plus 7x minus 3. Keep these brackets on because now we're going to expand times by x minus 2. So we've got 6x cubed minus 12x squared plus 7x squared minus 14x minus 3x plus 6. Okay, collect like terms, so 6x cubed, and then we've got minus 5x squared minus 17x plus 6, and that is our final answer. Okay, just be careful with these, don't rush them, make sure you get them right. Here's question 4, expanding the brackets. Okay, so claw method, 15y plus 12. Okay, claw method again here, so we've got 15x squared minus 25x cubed plus 10x to the 4. Again, I always like to write this with the highest x power first and the lowest x power last, just nice and neat. See? Okay, let's do this in a couple of steps, as many steps as you need. 10x squared plus 15x, take away 2x, and be careful here with the negatives. Okay, so plus 6x squared. Collect like terms, 16x squared plus 13x. Okay, and as simple as possible. Okay, we can factor back down. Sorry, it didn't say, it just said expand. Okay, but here we'd factor out this x squared. Here we'd also factor out the x step as simple as possible. But they just want us to expand, so we leave it like that. Sorry, 13x. Yeah, this is our final answer. Okay, D now. We have x squared plus 9x cubed minus 6x squared plus 4x. Yet again, they're trying to catch us out with this double negative. Don't fall into that trap. Okay, so minus 3x squared plus 9x cubed plus 4x. So 9x cubed minus 3x plus 4x. And that is our final answer. Question 5. Factorize these expressions completely. Okay, so we need to take the biggest thing possible on the outside. Alright, so don't worry about the big thing to start with. Just pick something to put on the outside and see if it is actually the biggest thing. Okay, so for A, I know I can take x out the outside. I can't see anything else, so I need to add 3x in the inside because 3x times x gives us x squared and then plus 4. Okay, and obviously these two don't share any common factors other than 1, so I know I'm done. Okay, part B, I can see a y is shared in both, but then also a 2 because both from even numbers. Okay, now 2y plus 5 on the inside, because if we were to expand this, we'd come back to what we need. Okay, and 2y and 5 definitely don't share anything, so that's how we know that they're completely factorized. Okay, now here, great point. We know an x in all of them. Okay, so we open that up, and then on the inside we get x plus y squared. Okay, and none of these share a factor, so we can't simplify this anymore. Okay, I'm also looking out to something that we can maybe do a double brackets here, but there's nothing that we can do. Okay, now for D, we've got definitely a 2 because they're even numbers, an x and a y. Okay, now what do we need to times 2xy to get 8xy squared? Well, we need to times it by 4 to get our 8, no x but a y, and then we need to add this to 5 times by 5 to get our 10, and an x to get the x squared. Okay, and that is question 5. Question 6. Now, I know how tempting it is to pick up your calculator. Those that have figured out the wonders of the Casio FX991EX class whiz can say, oh, I can put it in my calculator and it gives me the answer. Okay, you should be able to do this without the calculator. Okay, very, very important to know how to do these. Okay, part A. So we need to do two numbers that times together to equal 2, add together to equal 3, positive 2, and positive 1. Here factorising, we're trying to find common factor of both of these. Well, both of them have an x. Both of them can be divisible by 3. Okay, so we'll see where that gets us. X plus 2, or x and 2 share nothing, so that must be fully factorised. Part C. Okay, two numbers that times together to equal 35 and add together equal negative 2. Okay, so 7 and 5 times together to equal 35, okay, but we need negative 35 and we need negative 2, so we're going to make the 7 negative, because then when you add 5, that will give us our negative 2. Oh, not 2, that's 5. Perfect. Okay, two numbers that times together to equal negative 6, but add together to equal negative 1, negative 3 and positive 2. Okay, now what we have though is we have 2x. Okay, so we put in our 2 here, and that then decreases this x plus 2 to be x plus 1. Okay, you can check all of these by doing a little bit in your head. 2x squared, okay, plus 2x minus 3x is minus x minus 3 as needed. Okay, now E. So 5 times 6, so you have minus 30. You're trying to find two numbers that times together to equal minus 30, but add together to equal minus 13. Okay, 3 and 10 should jump to mind. So what is going to be what? Okay, that jumps to mind, but that is incorrect though, sadly. Okay, because we need both of them to be negative to make negative 13, but then when you times them together, that's positive 13. Okay, so even though weirdly so that worked for one of our conditions, it failed for the other one. Okay, so the other thing that we can look at is negative 15, sorry, and positive 2. Okay, so listen, that's right, because negative 15 plus 2 is negative 13. Okay, and now we need to think of how we're going to work this in with the 5. So 5 is going to times, okay, let's just write 5x here. Okay, because we know it's going to take this format. Okay, now 5 times our negative 3 will make our negative 15. Okay, so then our positive 2 goes here, which will times to make our negative 6 and our plus 2x. Okay, and yes, then we can check. Hopefully that kind of understanding makes sense. Okay, we should be doing this type of stuff at GCSE. Nice little recap, so I can skip some of the steps. But if you're really struggling, just comment below. All right, next we've got negative x squared minus 5x plus 6. I always like to rewrite it this way. That throws me off doing it backwards, but it's not needed. Okay, so we need two numbers that times together to make negative 6. Why negative 6? Well, like when we have a 5x squared at the front, we do 5x times that number. When we've got a negative 1 at the front, we do negative 1 times that number. Okay, so two numbers that times together to equal negative 6, add together to equal negative 5. We've got negative 6 and positive 1. Okay, so let's write out our brackets like we did beforehand. So we need a negative 6. So we do positive 6 here. That will make our negative 6x. And then we have positive 1 here. Okay, a little check. Negative x squared, negative 5x plus 6. Factorizing, it's not interesting. It's got to be done. You've got to be able to do this. Okay, so part A, we've got to find the common factor, which both are divisible by 2, both are divisible by x. And then what does 2x times get 2x cubed? X squared. What does 2x times get 6x? 3. Okay, and this is definitely fully factorized because x squared and 3 share no, well, 1 is the highest common factor. Okay, part B. Now both of them share an x. Now we've got x squared minus 36. Okay, and this is the part you can't just stop here. Okay, this can be factorized further. Okay, this should ring a bell from GCSEs, and let's factorize this further. So x minus 6, x plus 6. Okay, kind of the square rule here. Okay, should scream a bell when we've got x squared, take away a square number. Good. Now, we can definitely factor out an x, so let's do that. We're left with 2x squared plus 7x minus 15. Okay, now we've got a quadratic equation. Okay, and what have we got? 2 times minus 15, so we've got minus 30. We need to find two numbers that times together to make minus 30, but add together to equal 7, and I've got 10 and negative 3. So, these always confuse me. Okay, so I'm going to write this like this. Okay, because we know that this 2x needs to times by x to make x squared. Okay, and now we need to make a 10x and a negative 3x. So we need to do 2x times 5 will make our 10x, and then negative 3 times x will make our negative 3x, and then that makes our negative 15. Okay, so our final answer, question 8, and we're simplifying. Now, with these division, always write it as a fraction. Okay, it makes it a lot easier to work with. So we've got x to the minus 3 at the bottom, so it's times top and bottom by x cubed. To cancel that, so we get 9x to the 6 over 3, divide by 3, we get 3x to the 6. Perfect. Now, here we've got to be really confident with our indices laws. Okay, when you've got something to the power again, you're timesing these two powers together. Okay, so this is 4 to the half, and we know that 4 to the half is the same as square root of 4, which is plus or minus 2. Don't forget this plus or minus. Part C now. Okay, so we do 3 times 2 first, which is 6. X to the negative 2 times x to the 4 is x squared. Okay, because we're doing 4 take away 2. So all testing our indices laws. Yet again, we've got another division, so make sure to write this as a fraction. 3x to 2/3. Okay, now let's kind of split up this fraction a bit. Let's do the numbers first, a half. Okay, and then we've got x to the 3rd over x to the 2/3. Okay, when we've got a number over another number, okay, we take them away now. When you times them together, you add them. When you divide them, you take them away as opposites. Okay, so we get a half of x to the 3rd. So a 3rd take away 2/3, which is x to the negative 3rd. Okay, and this is in the simplest form, half x to the negative 3rd. Okay, this also looks like, if curious, 1 over 2 x to the 3rd. You can write that as 1 over 2 cube root of x. Okay, but any one of these three is fine for simplest form. Evaluate these two. Let's start with A. Okay, there's two ways of doing this. All right, you can find the cube root of both and square it, or you can square both and then find the cube root. Okay, hopefully you can identify which one of these two is way easier to do. Okay, we know the cube root of 8, which is 2. Cube root of 27 is 3. Then we square it, which gives us 4 over 9. Okay, and that's our final answer. This other way would have taken us a lot longer. Okay, now let's look at part B. Okay, same again. There's two routes that we can go, and cube rooting first, or in this case square rooting, is definitely easier. We get our number smaller if we're meant to do this in our head, and then we can then make it bigger. Instead of bigger and then smaller is a lot more difficult, okay? But obviously it depends case by case, it depends on the number, okay? But this is here for if it's a non-calc, to show awareness or just a bit of problem solving here, okay? Because all the maths papers are calculator at A level. Okay, so square root of 225 is 15. Square root of 289, okay? By the way, just on that calculator point, even though all of the A level papers are calculator, okay, stuff like this, this is what does your problem solving. Okay, stuff like this, stuff that you can do mentally. All right, and lots of people say, you know, well, how did they get the answer from there? How do they pluck it out of thin air? But they're not willing to kind of take the time to maybe do some of these questions with non-calculator, which kind of builds that thinking. Okay, so 15 squared. Okay, obviously I can put square root 289 in my calculator and see what it comes out as. All right, but we're not going to do that. Okay, we're going to have a little think of how we can best figure out what this is. Is it going to be 16 squared? Okay, because it's close to 225. No, it's not. Why not? Well, because this will end in a 6, right? Because we've got 6 times 6, 36. Okay, is it 17? Well, 17 squared is, 7 squared is 49. Okay, so that is hopeful. So let's kind of check that here. 17, so 9, 4, 11, 0, 7, 1. Okay, 289, exactly. Okay, so it's 17 squared, and this is plus or minus. We've got to remember our plus and our minus. Okay, now we cube this. Okay, now here is something where I admit, yes, using the calculator, I'm not going to waste your time and do 17 times 17 times 17. Okay, bit tedious, not worth it. This is good to go into your calculator. Question 10. Now we need to simplify these surds. Okay, and what comes to mind straight away is timesing 63. Okay, is divisible by 7 and 9. Okay, so we can write it as 3 root 7, which is 1 over root 7. Okay, times top and bottom by root 7, which is root 7 times bottom by root 7 over root 7, which is a 7th root 7. Okay, now this might have not come to mind. Okay, obviously in hindsight, it's great. I know that was helpful. Okay, but we'll just simplify it. Okay, say if you could have spot this straight away, what is divisible by 63? Well, you know 3. Hopefully you can spot 3. Okay, so that's 21 times 3. Well, 21 divisible by, what's it divisible by? 3 and 7. Okay, root 3 times root 3 times root 7. And there you go, 3 root 7. Okay, another tip is always look for square numbers. Okay, whenever we're simplifying surds, look for something you can square number. So can it be divisible by 4? Can it be divisible by 9? Can it be divisible by 16, etc. Okay, those are always helpful. Okay, part B now. 20. Okay, now if we're doing this checklist, well, 20 is divisible by 4. Okay, so root 20 is root 4 times root 5, which is 2 root 5. And 2 root 45, well, root 45. Is it divisible by 4? Not quite. Is it divisible by 9? Yes. Root 5 times root 9, which is 3 root 5. Okay, so 2 root 45 is 6 root 5. Perfect. Minus 80. Okay. Root 80. Divisible by 4? Yeah, it's divisible by 4. Perfect. Okay. Root 20 times root 4. Okay, we've already done root 20, which is 2 root 5 times root 4, which is 4 root 5. Okay, another thing here is we've got 16 times 5 is 80. Okay, so we could have gone over here, but everything divisible by 16 is also divisible by 4. So perfect. If you spot that, perfect. Okay, but if you didn't, then that's fine. So rearranging what we had into the equation then, root 20 plus 2 root 45 take away root 80. Was that the equation? Yeah, that was the equation. So then we have 8 root 5 take away 4, so 4 root 5 is our final simplified answer. Here's question 11, and it starts off with just subbing into your calculator. Okay, so when you sub in x equals 25, plug all that into your calculator, the value that you get would be 21,877. Okay, part A is not interesting, that's why I kind of skipped it there. Part B though, by factorizing this expression, show that your answer to A can be written as the product of prime factors. Okay, that can be quite intimidating. We're talking about primes, we're factorizing what? Let's just worry about factorizing this expression first, and then we can come back to seeing how it shows it's a product of prime factors. Okay, so first we need to factorize. Okay, and as we usually do, we do 35 times 48. Okay, and that is 1,680. Okay, so we need to find two numbers that times together to equal negative 1,680 and add together to equal positive 2. Okay, now this is a quite tricky concept to think about. Okay, you need to be smart when you do this. All right, well, we need the numbers that add together to equal positive 2. So they've got to be close together. Okay, and as these numbers in the number line have got to be very close together, okay, only a difference of 2, then it's almost like finding this square number. Okay, what number squares to get this? Because that is, well, square number is the smallest difference. They've got a difference of 0 between each other. Okay, so what number squared gives us 1,680? So you can square root it, and that can be your starting block, and then you can work around there. Or here, I know that 40 squared is 1,600. Okay, and that's very close to it, so I'm going to divide by 40 and see what I get. So when you divide by 40, you get 42. Okay, which is exactly what we want. Okay, but here's the method behind it. Instead of just saying divide by 40, and then you're like, all right, you've got the answer. Great, but how do I create that myself? This is the thinking behind it. This is why we've divided by 40. Okay, now that's the figuring out the breakup. Sorry, this should be a negative 40x. Negative 40x plus 42x will give us a positive 2x minus 48. Okay, so we've broken it up into our 4 terms. Okay, now we need to find us in our double brackets. Okay, and we simply can't just write 35x and x like we used to do. Okay, because we've got 40 and 42, and those none of those divide by our 35. Okay, so we've got to think of something a bit different. Okay, we need to find two numbers that you can divide 35 by, that then also one divides 40, one divides 42. Okay, and there's not many that divide 35, so you can kind of do a checklist, or 7 times 5 is one that comes to mind. Okay, and 5 divides 40, 7 divides 42. You'll see in a second why that's so important. Okay, so let's label our 7x and label our 5x. Okay, now when we expand this, we'll get our 35x squared, and then we need to get our plus 42x, take away 40x. Right, that's how we need it. We're kind of reverse engineering this. So when we have our plus 42x, we need to add 6 here. And when we have our minus 40, we need to take away 8. Okay, and just as a final check, is minus 8 times 6 negative 48? Yes, it is. Okay, so 7x minus 8 and 5x plus 6. Okay, this is the factorization of our formula. Okay, perfect. Now, what did the question want? Okay, we've done the factorization. Show that the answer to A can be written as the product of two prime factors. Okay, it can be written as a product of two prime factors. So 21877 was our answer to A. Okay, and how do we get that? Well, if you were to sub in x equals 25 into here, okay, then you would get times those together, and that would equal 21,877. So they've given you a hand here. They've told you this is the method that you need. Okay, but how can I convince you that this then shows two numbers that can be written as a product of two prime factors? Okay, why is 7 times 25 take away 8 prime, and why is 5 times 25 plus 6 prime? Okay, why are these two prime? Well, and that's about why it's going to have to. Okay, they're going to have to be prime. Okay, because you're showing something. Okay, so let's just sub in, see what you get. So 725 take away 8. What does that give you? That gives you 167. And then you have 525 plus 6. That gives you 131. Okay, so these are your two product of primes. These are two numbers that times together. You times them together, you get 21,877. So that factorization has taken away the kind of trial and error. Now we need to make sure we can prove that both of these are prime numbers. Okay, and the easiest way to do this, okay, would be to check. Okay, 167, okay, cannot be divided by, okay, well, we know it can't be divided by 3, okay, because 150 is divisible by 3 and 17 is not divisible by 3, so it can't be divisible by 3. Can't be divisible by 4 because it's not even, so not even really quite checking that, sorry. Can't be divisible by 5 because it doesn't end in a 0 or a 5. Can it be divisible by 7? Okay, well, we have 70, 140, okay, then 27 is not divisible by 7, so it can't be divisible by 7, okay, you skip 8, skip 9, okay, 11, okay, can it be divisible by 11? Well, we've got 121, 132, which is, sorry, 11 squared, 143, 154, 165. Okay, so it's not divisible by 11. Is it divisible by 13? Well, 13 squared is 169. Okay, so we passed 167, so that's kind of our proving that 167 must be prime because it's only divisible by 1 and 167. Okay, and then we can then do the same thing here for 131. So 131 cannot be divisible by, well, 3, right? Because 120 is divisible by 3, and then 11 is not divisible by 3. 5 doesn't end in a 0 or a 5. 7, okay. Well, what do we know? Well, we know 140 is divisible by 7, so that must mean that 133 is, so then 131 isn't. So 131 isn't divisible by 7. Okay, we don't look at a 9, we look at 11. Okay, yet again, 121, 132, and then 13. 13 squared is 169, which is greater than 131. Okay, so here we proved 131 is prime. Okay, so both 131 and 167 are prime numbers, and when you times them together from this factorizing, we know that you get 21,877. Okay, so quite a tricky question, quite an interesting question, and let me know if you have any questions. Question 12, we need to expand and simplify. So we're expanding 3 root 2 plus root 10. Okay, can we simplify this any further? No. Okay, some people might think you can simplify this by breaking this up to root 2, root 5, but this is more complicated. Okay, because imagine if you kept breaking it up into, something like that. Okay, so think of the most extreme case of what you've kind of acted on to simplify it and question if it's actually simplified. I know you're getting smaller numbers, which is usually what it means by simplifying, but no, we want to write as little as possible. Okay, part B, we've got 10 plus 2 root 3, take away 5 root 5, minus root 15. Okay, now can we simplify root 15? No, because there's no square numbers that factorize root 15. Okay, so this is as simple as possible. Okay, I know it doesn't look very simple, but it's also part of being confident when you can and when you can't simplify any further. Okay, 6 times 4 is 24, minus 6 root 7, minus 4 root 2, plus root 14. Okay, yet again, can we simplify this any further? No, we can't. Okay, because there's no square number that we can divide 14 by, so we leave it like that. Okay, and that's the exercise. Mainly expanding, not really much simplifying doing there. Always leave it in as the smallest number of numbers as possible, if that makes sense. Question 13, and we're rationalizing the denominator. So rationalizing the denominator, what does that mean? Well, we need to take out this third, this square root 3 from the bottom. And how we do that is we times top and bottom by root 3. This is the same as just times it by 1, so we don't change the value. We get root 3 on the top, and the bottom we get normal 3. Okay, so this is a third root 3, hence we rationalize the denominator, which means there's no more square root on the denominator. Okay, let's pick up for the next questions. 1 over root 2 minus 1. Okay, well here to rationalize we're going to times it by plus 1. Okay, and we'll see in a second how that is helpful. Okay, so we have root 2 times root 2, which is 2. Then we have plus root 2 and take away root 2. Okay, that's why we did the plus 1 instead of the negative 1. Okay, always do the opposite of what's here, because then you will always end up with this cancellation. We've got the plus root 2 and the negative root 2, take away 1, which is then just 1 in the denominator, so square root 2 add 1 is our final answer. Okay, now we're looking at C. We've got 3 over root 3 take away 2, exact same method. Okay, we need to times by the root 3 plus 2 now. Okay, because this will cancel on the bottom. We get 3 root 3 plus 6 over 3. Okay, and now this plus 2 root 3 take away 2 root 3. So those cancel, and we just get left with negative 4. Okay, so we get negative 1 in the denominator, so we get negative 3 root 3 take away 6 as our final answer there. Okay, moving on to D. Now this question is just tricky because it's being annoying. But no, that's a bad mindset to have. You should be confident on every question, no matter the number, but I will be using a calculator to do these timesing. So what do we need to rationalize this denominator? Well, we need to times top and bottom by the opposite. Okay, so root 23 take away root 37. Okay, let's see what this gives us. Okay, so look at the top, root 23 times root 23 is just 23. Okay, now root 23 take away, so we take away 2 lots of root 23 times root 37. Don't worry, I'll simplify that in a second. And now we have plus 37. See what the denominator is doing? Well, we got 23 there, 23, and then we're doing the exact same cancelling here. So this would be, oh, sorry, didn't mean to do that. So this would be the negative, this would be the positive. So those cancel, and we're left with take away 37. Okay, now 23 plus 37, 60. Take away 2 lots of 851. Okay, had that in the calculator from before. Now 23 take away 37, and we get negative 14. Now we can simplify by dividing top and bottom by 2. And now let's get rid of that negative in the denominator, which leaves us with root 851 take away 30 over 7. Now we need to look at E. Okay, so I'm going to do across the side here. E. So we have 1 over 2 plus root 3 squared. So let's expand that fully. So 4 plus 4 root 3 plus 3. which equals 1 over 7 plus 4 root 3. And now we do the exact same rationalizing. Okay, so 7 take away 4 root 3 over 7 take away 4 root 3. Okay, so the top is going to give us 7 take away 4 root 3, and the bottom is where the magic happens, 49, and then we've got the negative and the positive that cancel, leaving us with negative 16 times 3. Okay, so 48, which is then a 1 on the denominator, so we get 7 take away 4 root 3. Okay, now let's look at F. Give ourselves space over here. So we have the exact same thing. We need to expand this being squared first. Okay, so we have 16 take away 8 root 7 plus 7. Okay, and if I'm doing these steps a bit too quickly, then just sanity check it for yourself to make sure you follow what's going on. 23 take away 8 root 7. Okay, now we're times in top and bottom by the opposite again. And let's see where this gives us. So we've got 23 plus 8 root 7 over 23 times 23, which is 529. And then the plus and the minus cancels again. So we get negative 64 lots times 7. So 64 times 7 is 448. 529 take away 448, we get 81 on the denominator. 23 plus 8 root 7 over 81. Okay, and 23 is a prime number, so we know we can't simplify that any further. And those are our final answers. Question 14, we've been given a cubic and we've been told that it equals this expression. Okay, but we don't quite know B and we don't quite know C, and we've been asked to figure them out. Okay, well, we can do this by comparing coefficients. Okay, if we were to expand this, okay, and we see where it gets to, trust me, it'll go quite well. Okay, so x cubed plus bx squared plus cx plus 3x squared plus 3bx plus 3c. Okay, now like we usually do, even though we've got letters here, we need to group like terms. So 3 plus b x squared plus 3b plus c x plus 3c. Okay, and what I mean by comparing coefficients here? Well, we're told that this equation is equal to our red equation. Okay, so minus x squared minus 17x minus 15. Okay, so we know that negative 1 is going to equal 3 plus b, so then b equals negative 4. Okay, so we also know that 3b plus c is going to equal negative 17. So we sub in our b, get minus 12 plus c equals minus 17. So c must equal negative 5. And we just double check, does that work with what we had here? C is negative 5 times 3, negative 15. So we get what we want. Okay, so we found the values of b and c. So hence factorize fully this equation. Okay, so let's write out what we had. So x plus 3, x squared plus bx plus c, x squared plus bx, so minus 4x, plus c, so take away 5. Okay, so we want to factorize fully, so we want to now factorize this equation here. Okay, so two numbers that times together to equal negative 5, add together for negative 4, and hopefully we should realize that that is negative 5 and positive 1. So here we have it factorized fully. Here's our first exam style question of mixed exercises 1. And we've got, given y is this, express each of the following in terms of k, x to the n, k and n constants. Okay, 2 marks here. So y is the power of third. So y to the third is going to equal what we have here to the power of third. Okay, that's the same as splitting these individually. Right, and third is the cube root. So the cube root of 64 is 4, and then 3 times the third is just 1. Okay, so here we have a quarter x to the 1. Okay, k and n are constants, well here k is a quarter and n equals 1. Part B, we have 4y to negative 1. Always like to write these y to negative 1 as a fraction and then sub in what our y is. So we have 4 over 1 over 64 x cubed, which is going to be 4 times 64 x cubed. 4 times 64 is 256 x to negative 3. Okay, so here we have k is 256, n is negative 3. Question 16, and we've got to rationalize this denominator again. Okay, when we know we can write it in this form, they've got no fraction. Okay, so that's how we know to rationalize the denominator. So square root 75 minus square root 50 times top and bottom by square root 75 plus square root 50. So we get that nice cancellation in the denominator that we need. So 5 root 75 plus 5 root 50 over. Now we've got 75. And then we've got the cancellation that we talked about. So plus 50, take away that, so we take away 50. Okay, so root 75 is 25 times 3, and 50 is 25 times 2 over 25. So root 25 is 5, so it's 25 root 3 plus 25 root 2 over 25, so this is just root 3 plus root 2. So then A is 2, B is 3. And that's our final answer. 5 root 11 minus 11 minus 25 plus 5 root 11. Now the simplifying bit, 10 root 11 minus 36. Okay, and that is our final answer. Well, we could group together 2 at the front, 5 root 11 minus 18. If we want to simplify it even further. Question 18, now it's telling us to factorize completely. Okay, so when you're saying completely, when it's 3 marks, it isn't just going to be one step. Okay, so the factorization that comes to mind first is taking away this x, and we get 1 minus 64x squared. 64x squared. Okay, 3 marks. Are we going to get 3 marks for just doing this? No. Okay, we can then factorize this inside as well. So we have x, we have 1 plus, so we find the square root of 64. Okay, which is 8. Oops, 8x. I'm going to keep that in because that is a good reminder that everyone, even the best of us, I'm not saying I'm the best of us, but yeah, everyone can make mistakes in terms of math. I was thinking 4, 16s, you know, squaring that. But no, square root 64 is 8. And then we can do a little check here. That would be 1. This would be negative 8 plus 8, which cancel. And then that's negative 64x squared. Okay, so here is our final answer. Okay, here we have 27 to the power of 2x plus 1. We need to write it in the form of 3 to the y. So this in y in terms of x. Okay, so we need 3 to the power of something. Well, we know that 27 is 3 cubed, right? 3 times 3 is 9, times 3 is 27. So instead of writing 27 2x plus 1, we can write 3 cubed. But all of this then needs to do the power of 2x plus 1. Okay, so we do 3 to the power of 6x plus 3. The key thing here is 3 is times by the whole of this. Okay, so we have this is equal 3 to the y. So y in terms of x, so then y must be equal to 6x plus 3. And that is our final answer. Question 20, we've got a 4 marker here, and we want to find a and b. Okay, as always when we have surds and we have a denominator, so we have a fraction, we need to rationalize this surd. Okay, so it's times top of the right hand side here by root 3 and the left hand side here by root 3. Okay, so we get 8 root 3 plus x root 12 times root 3 equals 8x. Okay, now the reason why I did root 12 times root 3 is because I know I can simplify root 12.
Okay, so root 12 simplified is going to be root 4, which is 2, times root 3 times root 3, 8x. Okay, so then we get 8 root 3 plus 2 times 3, so 6x equals 8x. Okay, and then 8 root 3 equals 2x, so then x must be 4 root 3. Okay, and x is in the form of a root b, so we have a is 4, b is 3, and that's our final answer.